Can I just check? This is my first lecture of the semester, so usually things go wrong, but can I check that people can see my screen and can hear me?
Hiya, yeah, can hear you and see the screen.
Great, thanks. Now, I don't tend to leave the camera on, so hopefully that doesn't put people off. Just give me a second now to organize myself here. Okay, so I am Dermot O'Connor. I'll be taking the first half of this lecture of this module, and Frank Walsh will be taking the second half, there or thereabouts anyway. So I sent out a Slack message to you there, and you have a link to this website, which is where we produce or where we publish all the material for the module. I'm not sure if anybody in the first semester, I think maybe Siobhan Rowan used this style as well for her module in the first semester, those of you that took the Agile module. So you'll be kind of familiar with the way this kind of works. This website now will grow over the semester. And so each of these cards, as we call them, kind of represents a topic. And behind each topic, there will be slides, and then there'll be lab work. I couldn't find an image that said lab work, so the only image I could get was one that said homework, which is a bit primary schoolish, but anyway, that's all right. So that's kind of the way things will flow from the website's perspective, anyway. Um, so I think I'm just going to get going, really. Oh, yeah, there is the issue of the timing of this lecture. I'll have to look at an alternative time if possible. It may be Tuesdays from 10 to 12 is one thing I saw when I got my timetable eventually there last week, where it was over the weekend. But maybe I'll communicate that kind of stuff to you over Slack after today. So I'm just going to start off by giving you a quick overview of the module, and then we'll get into the first topic. Now, just in case there are any initial issues that you want to bring to my attention or stuff that I might have forgotten in terms of, initial housekeeping stuff, is there anything that I haven't covered in terms of the whole startup aspect of this module?
I'm just wondering, sorry, do you know the practical class on Tuesdays? Are they also going to be recorded? Do you know?
You mean the lab classes? What we call them
Sorry, the
lab
last.
classes?
Yeah.
On Thursdays, isn't it? Isn't it Thursdays there?
Yeah. Thursdays,
Yeah.
3:15 through 5:15.
No, no, they won't be recorded. Really, actually, if I go into, let's say, this topic here, which is the first one, what you will be doing in the lab is essentially working your way through these labs, and they're very prescriptive. So, you almost wouldn't need anybody. You could work on these in your own time, unless, of course,
Okay.
you hit a problem. And if you hit a problem, then you can either communicate with us over Slack, or if it happens to arise during the lab, then you can bring it to our attention then. So that's the way the labs actually work. There won't be a need for us to kind of spend maybe 10, 15 minutes at the beginning of the lab introducing it. These labs, as we've written them here, are meant to be kind of self-directed in that sense.
That's perfect. Thank you.
Okay, so I am just going to quickly go through this kind of overview set of slides, and I'll use PowerPoint rather than PDF that you have there. So this is kind of the one-liner of what this module is all about. It's very practical based, and practical in the sense of this module is that, there's a lot of coding involved in it, so hopefully that's something that you like. And what we will be designing and developing, are what are classified as client-side rendering web applications. I'll explain what I mean by that in a couple of slides. But it's not only the development of the web applications, it's also the deployment of them to, as we say, deploying them to the cloud. Now, in particular, we will be using the AWS cloud platform. And also, the deployment will be characterized as a serverless deployment infrastructure. And we'll spend a bit of time talking about that in subsequent lectures. So it's all about development. It's all about web apps, specifically client-side web apps. It's about the deployment of those web apps to the cloud. And it's about using a serverless architecture style in that deployment. And it's also about the automation of the deployment. We don't want to have to do a lot of clicking and entering command line instructions and dragging and dropping and all of that kind of stuff. That's a very manual approach. We want to automate it. And we'll see how that's going to be achieved. So that's kind of the one-liner. So initially, all I really need to explain is what do I mean by client-side rendering. All of the other stuff, there's no point in going into it now. That's what we will be covering in subsequent lectures. So as a start off, we need to understand what do we mean by client-side rendering web apps. So that's what I mean by the context here. I'm going to set the context for this module. Talk a little bit about the module's focus and any initial kind of software that you may need to have installed on your laptops, although I think there's a pretty good chance that you already have most of them installed anyway, but we'll see. So I said we are interested in developing client-side rendering web apps. There are essentially two classifications for web apps. There are server-side rendering and client-side rendering. And what the image here is kind of illustrating is that in a server-side rendering, the server does everything. So this is my client, which of course is a browser. This is my server, and the server is really responsible for everything. In particular, it's responsible for generating the UI, which, because it's web-based, means it actually generates the HTML that it wants to have displayed. And it sends that HTML to the browser, and the browser displays it. If the user interacts with it, that typically means that the user wants to make some change to the user interface. Maybe you request some data or change data or generate some sort of a report or something like that. Either way, their interaction will almost immediately involve the browser sending a request back to the server. The server maybe does some processing, some algorithm runs, it talks to a database, but it again generates the UI, whether that be an update to the existing web page that's being displayed or a completely new web page. Either way, it generates all of the HTML again, sends it back to the browser, and on it goes. Right. So the server is doing everything. The browser, we say, is kind of a dumb client. That's server-side rendering. Now, server-side rendering is actually quite popular. It was the initial style for web apps, and web apps have been around for over nearly 2 decades at this stage. That was the initial model. Then maybe within the last 10 years, it switched to a client-side rendering, and it's kind of going back to server-side again a little bit, but both styles are relevant to today. Anyway, that's server-side rendering. That's kind of high-level idea of how it works. Client-side rendering, the browser now actually has some logic that executes within it, and it's actually the browser is generating the UI in this case. So there's a lot of JavaScript code that is actually downloaded to the browser, And that JavaScript code executes within the browser, and it is responsible for generating the initial UI, the initial web page, and any interaction that the user carries out. That will cause the JavaScript to update, change the UI. It will also involve it talking to the server side. It may say, I want some data from the database, or I want you to perform some processing of certain data in the database. Server does that. So the algorithms and the data processing, that logic is still here. It's located here. And the result of any processing or algorithms that it executes, which usually means it results in generating new data or information, it sends that back to the browser. And the browser, the JavaScript code here then is responsible for kind of stitching that data into what is being displayed on the screen. So there's a lot of work now being done on the client side. And this is the model, the web app model that we will be covering in this module. The second half of the module really will be all about this stuff here. The first half is more about what's going on over here. So we are focusing in on client-side rendering, and really, when we drill down a little bit lower into that architecture on the server side anyway, there are typically actually two servers at play. This server up here is just a standard HTTP web server, like your standard website type server. And what it is responsible for is sending all of the JavaScript code, which is resident on some sort of file system that it has access to. It grabs that JavaScript code and sends it down to the browser so that the browser can now execute that JavaScript code as we had on the previous screen. The second server down here is what we call a web API server. So if I go back to the previous screen, in a way, like it's as if this is really made up of two parts. There's the web server part, and then there's the web API part. And they can be co-located within the one server, or they can be separate servers. So this part of the server side's behavior, this is where the kind of algorithms and data processing is going on. Yeah, so it's only data that's being transmitted in either direction, really. If the browser, the result of the consequence of the user interacting with the browser may cause a HTTP post request to be sent to this. So the post request will include data, as you know, and it may do some validation of it and store it in the database and all that kind of stuff. So that's a slightly deeper look at what's happening for client-side rendering web apps. And some of you may be very familiar with this kind of stuff already. That's okay. What I'm showing you here is the kind of communication flow. As I was saying, what I'm showing you here is the typical communication flow for client-side rendering web apps. And sort of initially, the communication between the browser is with the web app is with the web server, the top server here. This guy, yeah. And that server then kind of grabs all of the kind of web assets, the initial HTML page, which is really just an empty page. A lot of JavaScript, obviously a lot of CSS as well. They're all sent back to the browser. Then the browser executes the JavaScript code, and that's what generates the kind of home page, if you like, of the web app. All subsequent communication is then between the browser and the second server, the web API server. The first server now is kind of out of the picture. And so there's a lot of gets and posts happening between the browser and the web API server. Yeah, so that's kind of that's the communication flow, if you like, behind the scenes. Web apps, I'm not going to go through all this, but web apps have been around for, as I said, for about 2 decades. Sorry, CSR there at the top stands for client-side rendering. These client-side rendering web apps have been around for as I say, about 2 decades. And initially, like there was a heck of a lot of JavaScript involved in them. The JavaScript code was very poorly structured. There were no good design patterns for design patterns as a module that some of you are studying in this semester. There were no recognized design patterns for in terms of how you should structure your JavaScript code. So there were real nightmares really to try and program and maintain. Excuse me. They also lacked what's called addressability. You know the way a typical website works, just a standard website now, as you click on links and navigate around a website, the URL in the browser changes as you navigate around. So that's what we call addressability. Each page has its own unique address. Well, you didn't have that feature in the very first generation of these client-side rendering web apps. Even though you thought you were navigating around different parts of the web app and what you were seeing on the screen was changing. But if you happened to glance at the URL at the top of the browser, it never changed. And that's because really the JavaScript code was just generating the updates to your UI. That was the very first generation. Then a kind of revolutionary library came along called jQuery, and it addressed all of these issues up here about the code itself, and massively reduced the amount of JavaScript code that you had to write. But the addressability issue was still a problem. The kind of third generation, which is where we are now really, is where these what are called single page app frameworks came along, and they dramatically improved both the structure of your JavaScript code and also it dealt with the addressability issue. Okay, I don't really want to spend too much time on this slide really. You can go back and read over it yourselves if you want to. Anyway, so CSR is the context. Client-side rendering is the context really for this module. In terms of the technology stack then that we want to use, so on the client side, which is all of this stuff that I've enclosed in that red line, we're going to be using a framework called React, a single page app framework. I mentioned that there on the previous slide. Current generation is where we're using these things called single page app frameworks to develop client-side rendering web apps. And there are many, many frameworks, options available to us, but probably a lot of you may have heard of this framework called React, and that's the one that we will be using. That'll be the second half of the module though. React is nothing other than a JavaScript framework for creating UIs. You know, it's as simple as that, even though it's quite a hefty piece of software. On the kind of on the server side or the web API side, then sorry now, just give me 1 sec again. When you're ever presenting in Zoom, things start popping up in front of the presenter that the audience can't see, but okay, I've gotten rid of that. Yeah, on kind of the back end of your client-side rendering web apps or the web API side, we will be using the AWS platform entirely for hosting that, and it will dictate how we structure the code at our back end, and that'll be the first half of this module. Okay, so from a tech stack point of view, they are the technologies that we will be playing around with. This is roughly how things will pan out over the semester. We'll start off on the back end or the server side, the web API side. Then you will move on in the second half to the front end. And if we've got time at the end, then we will show you how you kind of integrate the two of them all on the AWS platform. We're going to be implementing both front end and back end in the TypeScript language. So I do need to give you a kind of a crash course, initial crash course on TypeScript. Okay, software installations. We use VS Code as our IDE stroke editor. We don't really care whether you would prefer to use something else. It doesn't really matter to us, but that's what we will be using. And as we demonstrate stuff in the lectures, it's the VS Code we will be using. If you're not already familiar with it, probably most people are at this stage, I'd say, but if you're not already familiar with it, I would strongly recommend using it because it's extremely popular in the industry. You need to have installed Node.js. Most people, I guess, or a lot of people would have Node.js already installed on their laptops. If you don't, then you need to install it. Pick about version 22 dot anything. If I just switch over to the Node.js, if you're not at all familiar with Node.js, then there is just one thing to be aware of, which is this is the Node.js website. And if you go to downloads, you can pick the version that you want to install by just selecting this drop down. Now, oddly enough, don't pick the version that's called current because that tends to be experimental. Pick the LTS version. That's the production standard one. So it looks like as of today, we're up to version 24. Now, I have version 22 installed on my laptop, so you don't actually need to have the absolute newest version of Node.js. Anything above 20, to be honest, I think would suffice. But if you don't have it installed at all, do not pick version 24 or whatever this full version is, because there may be aspects to it that might cause us some issues. That's Node. We use the Git source control tool a lot. And again, just check to see if you've got it on your laptop. Most operating systems include it by default. So it's a rare case when you wouldn't have it installed already. If you don't, well, in fact, if you did the Agile module in the first semester, Siobhan would have used Git all over the place. So, and we use it here as well. We also kind of do a certain amount of stuff at the terminal prompt level. So you need to be comfortable navigating around your folder structures, and all of that stuff. You need to create an AWS account for yourself, or an account on the AWS platform. Now, some of you would have done the cloud infrastructure module in the first semester, and the account that you used for that module, those of you that did sit in on that module, that account is not sufficient for this module. So you will have to create your own AWS account. Now, when you do create an AWS account, there are two options that it gives you. It gives you the free tier option or the paid tier option. You're actually going to have to pick the paid tier option. Now, if you're wondering, am I going to be incurring a lot of costs? The answer is no, you won't be, because we'll be using these serverless services on AWS. We'll talk about that later on, but one of the characteristics of serverless services is that you're only charged for how much you use. And we will be making very little use of it, relatively speaking, anyway. So I would see nobody incurring more than maybe $20 in the entire semester, provided you follow our guidelines in terms of deleting resources as you don't need them. But so again, I'll say, as you're creating your AWS account, when it comes to the choice of picking the free tier or the paid tier, you will have to pick the paid tier, because some of the services that we will use won't work on the free tier. You will also need to install the AWS CLI. Again, those of you that looked at the cloud street or that covered the cloud architecture module in the first semester will have the CLI, but if you don't, you do need to install it. And I'm just showing you on the right here that I don't really care what version of the CLI that you have installed as long as it's version 2 dot something. Version 2 dot something. Version 1.x won't suffice for this module. Familiarity with the AWS Management Console. Some of you may have some initial challenges getting familiar with the Management Console, although I wouldn't see it as a major drawback if you're not familiar with the AWS Management Console. As certainly from my half of the lecture, it's really me that will be using the AWS side. Frank in the second half won't be that much. But as you will see in my lectures, I do a lot of demonstrating. And so I will be demonstrating using the Management Console. So if you've not already looked at it, you hopefully get familiar with it as a result of following my kind of demonstration of it. This is the last slide. I didn't use this term full stack web app. And if you've read anything around web apps within the last 3 or 4 years, then this term full stack is a term that you would have come across. And really, we could say that what this module is about is developing full stack client-side rendering web apps. Yeah. And I'm just putting serverless here kind of in brackets because that's more in terms of the underlying infrastructure. But full stack is a term now that is very common in the web development world. I guess the reason we didn't call the module full stack was because that term didn't exist when we created this module initially, and the module has evolved over the years. Changing module names can be a bit challenging in terms of our internal kind of academic processes that we have to go through. So we're sticking with the old name. I probably should have said at the very beginning, actually, the module is called Enterprise Web Development. The use of enterprise is not that significant. I guess the enterprise is there because the technology stack that we're using would certainly be enterprise standard web technology. But other than that, the use of the term enterprise within the title is not significant. And here I'm just showing you, okay, React is positioned here. Over here, I'm using Node and Lambda, which is the predominant serverless service that AWS provides. We'll talk a lot, be doing a lot on that. And in the coming weeks, our database that we're going to use is actually DynamoDB, which is AWS's NoSQL, I guess you'd call it, database service, or one of their NoSQL database services. They have more than one. Okay, so that's a bit more detail on the tech stack. And that's it. Oh no, that's not it. The last point. Well, that's just summary, really. We're just summarizing some of the stuff. I'm not going to do that. People obviously are interested as well as in the assessment methodology that we use. Now, I haven't had a chance to speak with Frank actually, but I can tell you what we did last year. It's likely that we'll do it again this year. But I do need to speak to him. But what we did last year was there were 2 assignments, one front end, one back end, and there was also a lab-based exam at the end as well. So and I don't have the exact percentages breakdown, but the lab-based exam I think last year was maybe about 30%. But I'd have to talk with Frank and I'll give you a definite breakdown on that next week. Now, that's my overview, Maria. I'll just pause for a second in case there are any questions so far. I should have said too at the beginning, actually, I do tend to talk quite a lot in my lectures anyway. And if you need to ask questions, don't be shy. Just feel free to interrupt me, or I won't consider it an interruption. Just speak out if you can, and I prefer questions that way rather than typing questions into the chat facility within Zoom, because to be honest, I don't tend to monitor that as I lecture. So don't hesitate to stop me and ask me questions at any stage. Right, back to the website. Uh,
Um, I have a question. Hello.
Hi, I can hear you. Yeah,
Yeah.
great.
Oh, you can hear me. Oh, so I was just wondering, do we get the recordings like today, or like in what time? Like, are we supposed to get the recordings so that we can study the recording over and over? And yeah,
Yeah,
that's it.
what I do anyway, and probably Frank is much the same, is I do a tiny bit of editing of the recording and then I publish it on YouTube. But I should have said that as well, and I didn't. Here is where you'll find the recordings. So at the moment, there's none, obviously. But after today, or maybe early tomorrow morning, there will be a card here. And when you click on that, that will bring you to the video on, in my case, and I think in Frank's case, we both put them up on YouTube.
All right. Thank you.
Good.
So, hey, hi.
Hi.
So all the lectures will be online, or is it?
All of the lectures will be online. The labs will be in person, but I think in many cases, um, you may not have a whole lot of questions to ask us in the labs. As long as you work through them, we're happy with that. But we will be physically turning up in DO5 for the labs, just in case some people prefer to kind of ask questions face to face, or they may have other
Yeah.
issues related to the module that they prefer to ask us face to face, and that's fine.
Yeah. Okay.
Yeah, that's the way that works. Okay, so we are going to be using TypeScript throughout this module, front end and back end. You wouldn't typically, maybe might not be the first choice that people would use at back end, but rather than covering two languages in the one module, we're using one. So I want to quickly work my way through these slides. I don't think I'll get through them all today. I wouldn't expect to, and that's okay. Those of you that are comfortable enough or may have played around a little bit with TypeScript, you can certainly start off the lab and see how far you get. And even if I don't finish these slides, which as I said, I don't expect it today, see how far you get in the lab anyway, in your own time. And now, just for this week, I won't be able to attend the lab. I just have another appointment on the Thursday. So unfortunately, I'm not going to meet you in the lab this week. But if you're working your way through it and you're having any issues, do contact me by direct message or even on the general channel on Slack, and I will deal with it as quickly as I can. Okay, so let's bring up these slides. Now, as I work my way through these slides, there'll be code excerpts that I'll be demonstrating and explaining. And if you want to get access to that code, you'll find it at this GitHub repo, which you can clone for yourselves. So TypeScript, if you've read anything about it, it's essentially it's JavaScript with a data typing system layered on top of it in very simple terms. And TypeScript is a compile time language. There is no runtime environment for TypeScript. So what happens is you develop your code in TypeScript, but that has to be compiled into JavaScript. And then you run your JavaScript in your JavaScript runtime environment. In our case, that will be Node, but there are alternatives to Node as well. So a lot of people, even people that have played around with TypeScript for a while, they still don't realize that there is that distinction, that it is really only a compile time language. It's clearly based on the JavaScript syntax. Sorry now. I'm trying to get my pen up here. Why doesn't that work? Okay, my pen doesn't want to work. I'll keep going. Oh yeah, ECMAScript. If you've read any, if you've done anything on JavaScript, you will have heard of ECMAScript. ECMAScript is the specification for the JavaScript language. Or put another way, JavaScript is an implementation of the ECMAScript language specification. And TypeScript is, and this ECMAScript specification has evolved over the years. And so TypeScript is based on two particular versions of the ECMAScript language. Version 6, which is around then. Sorry, version 4, which was around then, and version 6, which is around 2015. The 2015 one was a fairly revolutionary one in the evolution of the JavaScript language. So this guy, Anders Hellsberg, who developed the TypeScript language, he based it on these two specifications for the JavaScript language. And yeah, so really, okay, you're writing TypeScript, but what you're actually running is JavaScript. And you never really need to look at the JavaScript that's generated by the compiler. That kind of defeats the whole purpose. So you stay in your kind of TypeScript world, and you let the compiler take care of generating the executable version of that. These two quotes down here were from two kind of luminaries in the JavaScript world. Everybody hopefully would have heard of Bernard Eich. He's the creator of the JavaScript language, and so what he said about TypeScript is that its use of type inferencing is really what's made the language as popular as it is, and we'll talk about type inferencing in a while. TypeScript was really designed for large-scale applications. The JavaScript language is fantastic, but it has a number of kind of weak points in it. And certainly if you've got a large code base and you're trying to do some debugging, a large JavaScript code base, and you're trying to do some debugging, it can be pretty much a nightmare, really. Now, TypeScript is much easier to debug, and it's really aimed at large-scale applications. Now, we won't be dealing in large-scale applications, but that's where it really shines, if you like. GitHub publish, they kind of survey, GitHub surveys all of their repositories across the globe every year. And they publish a number of very interesting statistics in terms of their findings from that analysis. One of them is the popularity of languages on the GitHub platform. And so this I'm showing you here is telling us that the TypeScript language, because all of those languages that are listed on the right there, they're all much more mature than TypeScript. TypeScript is actually quite a new language, but it has already, certainly by the end of 2024, it got to position number 3, the third most popular language on the GitHub platform. And so there just last week, I said I'd go back and check to see the most recent GitHub analysis of the repositories. The analysis that they do, they publish it in a report called the Octoverse, and you can Google it and get some, have a gander through it if you wish. But when I looked at it last week to see, well, because you can see this graph here only goes up to 2024, I was wondering, well, it's probably going to be much the same for 2025. And it turns out that, and I think most people would be quite amazed by this, that in 2025, TypeScript went to position number 1 in terms of contributions to GitHub repos. So it's now the most popular language on the GitHub platform. And that's quite surprising for a lot of people, but there you go. They're not sure why it's gone to position number 1. It's not really linked to the AI revolution. Python certainly is, but there seems to be a movement towards type-safe languages or statically typed languages. JavaScript is not statically typed, as you know. At the bottom of the screen there, actually, I'm providing a link to that GitHub report for 2025. If you have an hour to spare any day, there are some interesting data there. I mean, they tell us about activity around the globe, where is what regions within the globe are very active on GitHub or have been very active within the last year. So I think they found that Brazil, for example, and India and Indonesia, there was a rise in popularity of the GitHub platform in those regions, for example. And there's other interesting stuff as well. Anyway, what's the upshot of this? The upshot is TypeScript is a good language to have on your CV, I guess. Let's get into the nuts and bolts of TypeScript. TypeScript files, they have the file extension .ts. So that's where you put your source code. You also have for the files with the .d.ts files, and that's typically where you would put definitions of your own custom data types. Obviously, the language comes with some built-in types, but you would declare your own types as well. And you can put those types into a .ts file, but from a code structuring point of view, it's better to put them into these .d.ts files. What I'm saying down here is, so when you're writing TypeScript code, obviously there's a heck of a lot of JavaScript libraries out there, third-party libraries out there that have evolved over the decades. And we'd still like to be able to use those JavaScript libraries, but they are written in JavaScript. And what a lot of the maintainers of those third-party JavaScript libraries have done in order to make them useful to TypeScript developers is they have included these .d.ts files with the JavaScript source code. And the benefit of that is that we get the benefit of type inferencing and IntelliSense, all of that within our IDE when we're writing TypeScript code, but we're using these third-party JavaScript libraries. So they're used there a lot, as well as writing your own TypeScript declaration files. They come with traditional kind of third-party JavaScript libraries as well. And I'm saying there at the very bottom, that makes the kind of tooling that we use, it benefits the tooling side of our TypeScript development. Every language has its primitive types, and the primitive types are pretty standard, really. So in the TypeScript language, we have the primitive types that I'm listing there, number type, Boolean, and so on. The null and undefined primitive types, they come directly from JavaScript. Everybody should be familiar with the undefined type in JavaScript now. And then outside of these primitive types, everything else is kind of inherits from the object type. And if you've done any JavaScript code, you know that the object type is really all over the JavaScript language. There is on the next slide then, what I'm showing you here is the kind of built-in type hierarchy that comes with TypeScript. So you can see here are the kind of primitive types that I've mentioned in the previous slide. And they all inherit from a parent called the AnyType, kind of an odd name, but it's kind of interesting. So this is the top of the TypeScript type hierarchy. And if you've got a variable whose type is the AnyType, you're essentially saying that it can be assigned any kind of value. If I just rewind for a little second, in JavaScript, as you know, if you declare a variable in JavaScript and you assign a string to it, for example, on the very next line, you can assign a number to that variable. And on the next line, you can assign an object to that variable. That's because JavaScript is a dynamically typed language. In TypeScript, you cannot do that, which is why TypeScript is a statically typed language. Now, if you declare a variable in TypeScript and you say to the TypeScript compiler, the type of this variable is the AnyType, then you're essentially back in JavaScript world. You're saying any kind of variable can be assigned to it. Now, clearly, that's something that you should not and you should not ever do, really. You need to avoid that, but it is possible, right? So this AnyType is somewhat abstract in a way, but it's both real at the same time. The void type that comes from, is that in JavaScript? It may not be in JavaScript, but where void can be useful is if you've got a function, for example, that has no return statement, then we say that function returns a void type. Undefined, that comes directly from JavaScript. Unknown can be useful as well, although we won't talk about it now. And kind of over here then on the right, you have the object type. And any types that you define yourself then essentially kind of inherit from this object type over here. There's some other ones there as well, but we won't get into it. If I go back to the previous slide, okay, that's all right. So from a syntax point of view, how do we tell the TypeScript compiler what type a variable is? And we use what's called this postfix syntax. So this simple declaration here, I'm declaring a variable called me, and this colon is followed by a type. So this is telling the compiler this variable can only be assigned values of type string. And that's clearly what's happening on the right-hand side of the assignment statement. But if we subsequently change the value of the me variable, then we will only be able to assign other strings to it. So this is this postfix syntax. It's really annoying me now that I can't bring up my pen. Let me just try one more. No. For some reason, my keyboard shortcut isn't behaving for me. Okay, I have to try and keep going. It just won't do it for me. Where are we? Okay, so this postfix syntax is how we declare a variable's type. TypeScript has the notion of typed arrays. Again, that's something you don't have in JavaScript. In JavaScript, when you have an array, you can have a mixture of different value types in it. This is the syntax for an array, this kind of square bracket, close square bracket. There is another syntax as well, we'll see later on, but this is the kind of simpler of the two syntaxes. So this looks like that this variable now is an array of numbers. Numbers is one of the primitive types. It doesn't have to be a primitive type. You can have an array of complex types as well, and we'll see that later on. And indeed, what's happening on the right is an array of numbers is being assigned. And we can change the array, obviously, but if we want to add new entries to this array, the only thing we would be able to add to it is a number value. Otherwise, the compiler will complain. This typing syntax, this postfix syntax, you also use it when you're declaring functions, as you can see in this simple example here. So we're saying this function, it takes two arguments, and in this case anyway, they're both of type number. And this part over here is telling us what the return type of the function is. So when you're using typing on a function, you're stating the kind of signature, the type of the signature for a function. It's all very straightforward, I think. TypeScript has classes, but really it's actually only using the class syntax that became available in JavaScript in 2015, part of that ECMAScript 6 specification. I'm not going to talk through this slide. Everybody is familiar, should be familiar with the notion of classes. On the right, I'm just showing you the syntax, excuse me, that you use with TypeScript. And there are just some facts there on the left-hand side. Like, for example, TypeScript only supports single inheritance. You can't have multiple inheritance. And you've got public and private properties and all of that kind of stuff. TypeScript also has interfaces. Again, I'm assuming people are familiar with interfaces from other languages like Java and TypeScript, but really it's JavaScript actually provided interfaces as well. And I'm just showing you the syntax there on the right for declaring interfaces in the TypeScript language. And I'm saying on the left that classes can implement multiple interfaces. We won't be writing a lot of classes, as it turns out. We'll be writing more functions than classes, but they're there in the language anyway. Now, something that is probably what you haven't come across before in other languages. In TypeScript, we call them interface data types, or IDTs. It's unfortunate that the word interface is used in them, but they are separate now from what we had on the previous screen. What interface data types allow us to do is to declare the structure of an object, where an object is a set of key value pairs, object in the kind of JavaScript sense. In JavaScript, when you have an object with a set of key value pairs, you can add new properties to that object at any stage. You can delete properties from it. There's no real template for the shape or structure of an object in JavaScript. And that can be a source of many, many problems. But in TypeScript, you have to state what is the structure of an object, and that structure can never change. So the way you do it is you assign an interface data type to that to your objects. And these interface data types we define for ourselves, because clearly the shape of objects varies from application to application. So there aren't any built-in interface data types, or at least there's none that I've come across in the language. And they're probably there actually, in fairness, but I've never had cause to use any of the built-in interface data types. But we define a lot of these IDTs ourselves. Syntactically, this is how we declare an interface data type. So there's that keyword. This is the name. So person now is the name of a type It's not the name of a variable, it's the name of a type in my TypeScript. And then we have the key value pairs, the names of the keys and the types of the values. And again, this is just the syntax of it. You need the colon at the end of each one, at the end of each property. Here then I'm just declaring a variable and its type is person. And so the key value pairs here have to match what's in the interface data type. Otherwise the compiler will throw an error. Let's break from the slides for a second. Let's switch over to VS Code. So what you're looking at here now, this project, I suppose we'll call it, you can get at all of this code from my GitHub account. I provided a link to the GitHub repo in the very first slide of this slide set. So if we just go through this, I won't go through every single one of them, but if we take the very simplest one, okay, here we go. We're declaring a variable, its type, assigning it a value, another variable, nothing too exciting. Making some changes, console log, that's all right, another console log. Now, if I just uncomment this line here, see what's happening. So my number up here is a variable of type number. And so clearly, if you try and do a to uppercase is a method associated with a string. If you try and invoke that on a number, then you can see that the compiler is actually complaining. In VS Code anyway, the squiggly line here is essentially a compiler error. Now, when you're using VS Code and you're writing TypeScript, you always keep the problems tab open, and that gives you the explanation of the errors that you might be having. So what's happening behind the scenes now, as you're actually typing code, your TypeScript code into your IDE, the compiler is working away behind the scenes, and it's compiling your code as you develop it. So it just doesn't like it. It's kind of telling us here that the to uppercase is not a valid kind of property of a number variable. Yeah. Sometimes these error messages are very useful. Sometimes they will take a little bit of time familiarizing yourself with kind of the language that they use. What's it saying here? Property, like it's saying that to uppercase is a property. That's because behind the scenes, numbers are actually kind of stored as objects, but we needn't go into that. The simplest translation is to uppercase is not a valid method that you can invoke. But the point I really want to get across here is that the compiler is working away, and it doesn't allow you to write invalid code. You see, if this was a JavaScript file, I would not discover that this line is an error line until I actually ran the JavaScript. That's when it might throw an error. Whereas with TypeScript, you're told straight away before you ever start running your code that there's a problem with, and you need to resolve it. Apart from the primitive types that I showed you there on the slide, there are some other useful built-in types. For example, there's a regex type for regular expression, and I'm just showing you a simple example of using this regex type, and you can look at that yourselves later on. They can be very useful using regular expressions if you're trying to validate certainly string data. So, and there are other built-in types as well. Here we just have an example of an array. So we've got an array of numbers, which we had on the slides, I think. This is the alternative syntax that you can use for declaring an array of things. So there's that keyword array, the angle brackets, close angle brackets, and then the type between them. Now, we don't tend to use this syntax when we're declaring arrays, but we do use it for another part of the TypeScript language called generics, and we'll see that later on. But they both mean the same thing. Clearly, this is less physical keyboard typing using this syntax here. What else? Oh yeah, well, yeah, if I uncomment this line, so there's an error. So this is an array, and push is a valid operation to carry out on an array, but I'm trying to push a string onto the array, and it doesn't like that because I said my array was an array of numbers, and so that's why we're getting this squiggly line. In JavaScript, there wouldn't be any issue with adding this string to this array because arrays in JavaScript are not type safe. Let's undo that again. Let's see what's going on here. Interface data types. So I've got a person data interface data type, and then I've got an instance of that. We've seen that from the slides. And doing a little bit more here, I've got a student interface data type with these properties. And you can see one of the properties is an array of strings. So, your interface data types can be as rich as you want them to be, depending on the nature of your data structures that you want to deal with. So I've got a student interface data type. I've got an instance of a student. That all looks good. I've got another interface data type, semester result. And semester result is made up of a module name and a grade. That's fairly straightforward. I've got a student exam profile, and here's the breakdown of it. And you can see this part here is using one of my other interface data types. So it's extremely flexible, I guess. What else is going on here? That's okay. That's just another, sorry, what's this in our student? Let's look at student exam profile. So it's a person property followed by a number property and then an array of semester results. And semester result is this structure here. So when we look at this in this particular variable, its full shape matches this interface data type. If I uncomment this, I guess, will I get an error? I wonder why I had that there now. Oh yeah. So this name property, what doesn't it like about that? Let's look at the problems. Oh, it doesn't exist, I don't think.
Module name, not name.
Yeah, module name, yeah. So, so that's the compiler again. That's just keeping an eye on you, essentially. And again, I've said it before, I know, but, in JavaScript, all of this stuff gets by, and it's not until you run your code and maybe discover after a number of days of your application running that it suddenly throws an error, and you're wondering, you're trying to debug why is the error, what's causing the error, because you might have had a number of these data structures which didn't have this line in it, and then an instance of this data structure occurs with a name property in there that shouldn't be there, and that's what causes your application, your JavaScript application, to crash, and you're trying to debug it. Whereas with TypeScript, it catches it at compile time for you. Okay. That's fine. Back to my slides. So we've interface data types really are the only new feature, I guess. You have something called type aliases as well. Type aliases is a very difficult thing to define in one line, but we do use them an awful lot though. Because what I actually did was I just asked AI, give me a one sentence definition of what a type alias is. And really what I came up with, I didn't think was great. So, and that's because these type aliases are used for a number of different aspects of your typing, your data typing system within your application. One thing you can use type aliases for is it's just an alternative syntax to interface data types. So if you see this example down here, right? So I've got this keyword type that tells me this is a type alias declaration that's happening here. I've got a name, and then I've got a structure. Now, you know, that's exactly what an interface data type is. An interface data type is about defining the shape or structure of an object. So you can use type aliases to define structures for objects as well. There's a slight difference in the syntax, like there's use of the equal sign here, whereas if I go back to interface data types, there's no equal sign. Other than that, obviously there's the keyword interface and the keyword type. But other than that, these can be used interchangeably. Now, a lot of people have asked the question, why did the person that designed Halsberg, that designed the TypeScript language, why did he have two different ways of defining the same thing? And there's no clear answer to that. But so this use case for type aliases, and there is absolutely no difference between this use of type alias and an interface data types. You can completely use them interchangeably. But the thing is with type aliases, you can use them for other stuff as well. And it's that other stuff that becomes really powerful. For example, I'm declaring a type here called alphanumeric. And the way you interpret it is you're saying an alphanumeric type could be a string type or a number type. And you can have any number of R's that you want to. So you interpret this as the kind of R operator. And here I'm declaring a variable. Its type is alphanumeric, and I'm assigning a number value. So from a compiler's point of view, it's happy. That squiggly line there is just something that VS Code, if you have a variable and you're not using it, the way VS Code kind of tells you, you may need to delete this variable because you're not using it. So that's what that squiggly line means. It's not an error. But on the very next line, I'm declaring another variable. Its type is alphanumeric, and I'm assigning it a string. And for this variable here, anywhere else in my code, I could assign a string to that variable, and the compiler won't complain. And equally, this variable, I could assign it a numeric value, and the compiler is going to be happy. So there may be cases where you have a variable, and in fact, it can take on more than one type of value. Now, if it takes on multiple types of values, then you maybe need to rethink your design. That's not a good idea because you're almost back to the any type at that stage. And that kind of brings me back to that, because if I just go back to here at that any type, as I said at the outset, you should never use it, but it's there, right? So you can see here, I'm declaring a variable and I've declared its type as being any. Don't ever do that, right? Because that's just means you haven't really thought about it. But so I've declared its type as any. I've assigned it a string. On the next line, I'm assigning it an array of numbers. And there's no red squiggly line, so the compiler is happy because you said anything could be assigned to this variable. So it is a type, but don't ever use it. Okay, so this is another use of this type alias idea. We'll actually see this again a little bit later on. Strictly speaking, what this is referred to is a union type. where you've got a type that's a union of other types. And it doesn't have to be primitives. You could have complex types here as well. Another use case for type aliasing is illustrated here. So what you're declaring here is a type. Always, you need to be clear on the difference between declaring a type and declaring a variable. Declaring a variable is something that you want to assign a value to. Declaring a type is declaring a structure for variables in your code. Now, where that kind of gets slightly confused then is this one here, right? So I am declaring a type here, but the way you interpret this is you're saying any variable whose type is going to be pet category, that variable can only have one of these values, which happen to be strings in my case, but it could be anything, right? It could be numbers, mixture of numbers and strings. And here I'm declaring a variable. Its type is pet category, and I'm assigning it the string dog. And that's, from a compiler's point of view, it's happy with that. Like if I assigned it anything else, like, I don't know, horse, then it's going to throw a compiler error because that's not a valid value for this variable. This is referred to as a literal type declaration. And these can be very useful as well. And there are others. So we've got 3 different use cases for this type alias idea. And there are other use cases, and we'll see them as we work our way through this part of the module. It's an extremely kind of powerful feature. I'm wondering why I have got that down there. Oh yeah, no, it's okay. The next thing is type inferencing. Now, if you had to always be explicit about the types of all of your variables, that really means you're doing you're adding an awful lot of syntax to your code. And arguably the TypeScript language may not have been as popular if it forced the developer to always have to be explicit about the types for the various variables that they're declaring. And this is where type inferencing comes in. And if you go back to the first slide when I talked about the background slide that I had in this set of slides, and it was a comment made by Bernard Eich, the creator of JavaScript. What he said he really liked about the TypeScript language was the fact that it had this type inferencing aspect or feature to it. And what type inferencing is where the compiler infers the type of your variable based on the values that are being assigned to it. And that means then that you don't actually have to be explicit. So if I give you a simple illustration, and we go back to the very beginning, go back to here. So it turns out I don't have to state that the type for that variable is string, because I'm not going to get any red squiggly line. And so what's happening here now is the compiler is inferring that the type for this variable is string. Now, how do I know what type it is inferring? Well, in VS Code, there is a keyboard shortcut. And in the case of a Mac, it's Command K, Command I. On Windows, it's probably Control K, Control I. But if I type that keyboard sequence, Command K, Command I, and if I do it again, see here, this is what's popped up, and it's telling me that the type for this variable is string. So the compiler is inferring that type for me. So that keyboard shortcut, Command K, Command I, or Control K, Control I, in case of a Windows machine, that's something that you might find yourself using quite a lot initially. In fact, initially what you'll probably find yourself doing is you'll find yourself being explicit about the types of your variables. But as you get more experienced with TypeScript, and really we're only going to be spending 12 weeks, so I wouldn't think anybody is going to be experienced at the end of 12 weeks through no fault of your own. But you may find yourself initially being explicit about the types for your variables, where in fact you could omit the type and the compiler will infer it for you. So that's type inferencing, where the compiler infers the type based on the value. And it's still fine, like this still is the type now, the type that has been inferred for this variable, that still holds for the rest of the code. Like if I try and assign a different type of value to this variable, the compiler is still going to complain because it knows the type is string. Something else I didn't show you is how do I run a TypeScript file? Because I've got some console logs, so this does actually output something. Well, I'll show you how to run a TypeScript. So if I bring up my terminal, did somebody want to ask me something? No. So if I just clear this. So the command is, or the CLI command is npx, not npm, npx, ts node. And then the name of the file. Now we're looking at file 00, is it? Index.ts. So what happens here behind the scenes, if I hit return, is this utility takes your TypeScript code, compiles it into JavaScript, and then runs that JavaScript on the node, on your whatever version of Node that you have installed. Node, as we know, is a runtime environment for JavaScript. So it's doing the two steps for you, rather than you having to compile it first and then run it. This is just a nice convenience utility that will do both for us. So hit return, and these are the various console logs that are in my code. That's all this file does, really. Just does. That's all it outputs. If you do want to compile it and you want to see, can I actually see the JavaScript compiled? So you can. And the way you do that is npx. So there's another utility called TSC, which I guess stands for TypeScript compiler. And if I hit return, and if I go up to the actual folder, the 00 basics folder up here, you can see that there is a JavaScript file. And this is the JavaScript. You never need to go looking inside the JavaScript, but there it is. And obviously, you don't find any type-related code inside here, because TypeScript is a compile time language. It's not a runtime language. That's the JavaScript that's generated from my TypeScript, and all of the type-related syntax is gone from it. So that's type inferencing. And that works for everything, really, for your own custom types as well. So kind of what we're seeing here is, here's a custom type of mine using in this case, I'm using type alias syntax, but I could have used the interface data type syntax just as well. Here so I've got an array. Sorry, no, let's start again. No, I'm not declaring a type. I'm just declaring an array. Sorry. I'm just declaring an array of person objects. And we had the person type there earlier on in our slides. So that's fine. I've got an array of person objects. and I'm invoking the filter method on my array. People are familiar with the filter method. And you pass the filter method what's called a callback function. And essentially, as you know, what the filter method does is it identifies particular entries within this array where the entry returns a Boolean true for this kind of function here. So in this case, I'm looking for each friend whose name starts with the letter S, whose last name starts with the letter S. That's just JavaScript, right? But from a type inferencing point of view, the compiler will infer that the type for this variable is an array of friends, is an array of person objects. And similarly, it will infer that this here, the parameter of my callback, that it will infer as being of type person. You could declare them explicitly, but you don't have to. And it does all of that because it knows about the filter method. It knows what it does because the filter method actually, behind the scenes, the filter method will have a type declaration file explaining the nature of this filter function and what its signature is, what type of arguments does it take, what type of argument does it return. Remember, I was talking about that in relation to third-party JavaScript libraries, that most third-party JavaScript libraries now come with a TypeScript declaration file associated with them, these .d.ts files. So the .d.ts file that comes with the built-in filter array filter JavaScript method, that would tell the TypeScript compiler that the filter method returns an array of objects of the same type as the source array. And my source array is an array of person objects. Therefore, this must be an array of person objects as well. So that's really where this type inferencing is quite powerful. The fact that the compiler can work out all of that without me having to tell it explicitly what are the various types of the variables being used here. I've already said that with functions, you use this type syntax as well, where you have to tell the compiler about the signature of your custom functions, signature in terms of the types of the arguments and the return type. So we saw that this simple example earlier on, and this we can see the syntax, the postfix syntax being used here, and here is where we're telling it what the return type is. From a type inferencing point of view, the compiler will actually in most cases work out what the return type should be. It won't necessarily know what the parameter types are going to be. You do have to be explicit about that, but it will work out what the return type should be by simply looking at the return statement in your function and evaluating the type of the value that's being returned. And that's what we're illustrating down here. Like you can do Command K, Command I on a function, and it'll return something like this, or it'll display something like this. And this is telling us about the inferred signature for your function. Should I look at some code? Just going back to this file. Let's see, is there anything else interesting here? Sorry, now let's go down to type aliasing. So we've seen all of that stuff. Type aliasing. Let's quickly go through this. So we're declaring a contact type here. As I said before, probably too many times now, I could have used the interface data types to declare this, but okay, so I've got a contact type. I've got an address. Sorry, no. oh no, I've got an address, sorry, academic entity type. And I'm saying academic entity could be of type student, which I declared earlier on. Sorry, that's course. Sorry, I didn't say content. Sorry, course. I've got a course type here. I've got academic entity. I'm saying it could be of type student, which I've declared earlier on in this file, or of type course. I've got a variable here, which is of type academic entity. I'm assigning student X to it. Student X was a variable I declared earlier on in this script, and it was a student type. So that assignment statement stands up based on this type declaration here, this union type. I've got a function that takes an academic, returns an academic entity, and sorry, it takes an academic entity. I haven't specified the return, but that's okay. I won't deal with that now. So because process AE can take a student or a course, here I'm invoking it. I'm not concentrating on the function now because that's not what I want to look at right now, but I can pass a student to that function, or I can pass this structure here. This is a course, so the function accepts both of those. We'll look at it later on, but clearly within this function, I do have to determine, because presumably the nature of the processing is going to be slightly different for a student variable versus a course variable. So you do need to determine within your function which particular type is it. Now I'm doing that here actually. Well, yeah, okay, I can discuss it now, I suppose. I'm looking at the parameter that's passed in, and I'm checking, does it contain a property called code? Now, if you look at my academic and my course type, it does have a property called code, but the student didn't have a property called code. So it can actually work out that from this statement here, the academic entity would be a course entity, and I will prove that to you later on. The compiler actually can work it out, that any references to the parameter, any reference to it inside here, it will know that its type is course and not student, whereas here it would be of type student. But as I said, I'll prove that to you later on. Type inferencing, I'm not going to go through that now. I think it's all fairly straightforward. Yeah, well, I was talking about this in the slides, right? But again, like if I go Command K, Command I on this variable here, try that again. Command K, Command I. And you can see like it has inferred the correct type onto it. And do I want to look at that? No, I don't. Let's switch over to the next file, which is in functions. Are we on time? Nearly running out of time. Okay, functions, we've seen that from the slides. Now, in JavaScript, we have this concept of arrow functions. I'm assuming people are familiar with that. Now, for declaring the type for an arrow function, that's what I'm demonstrating here. So here's my arrow function. Looks like it takes 2 parameters, which happen to be both of type string, and it returns a string. And you can see here, look, that this is really what is being returned. I'm hoping people know now that with arrow functions, if the arrow function is just a single statement, which it is in this case, this is the only statement within my arrow function, then you don't need the return keyword. It will default to whatever having evaluated the single statement within the arrow function, that will automatically be the return value for that function. And that's what's going on here. That's all JavaScript now, right? It's not a TypeScript thing. But from a TypeScript point of view, this is how we declare the type of the signature of our arrow function. That's all you can get from that example. Okay, here's just another function that I kind of dreamt up, and I'm coding it using the arrow syntax, but in this case there are multiple lines or multiple statements within the function, so I do need to use my curly braces, and I do need to have an explicit return statement, which I do. What the function does, it's a rotate function. The idea is you pass it a string and you tell it where the axis in the string is, and the function is meant to rotate the kind of source string around its axis. But just for the heck of it, I said that the axis could be specified as a string or a regular expression. If it's a string, then it simply looks for that string within the source string and rotates around that. If it's a regular expression, it looks for a particular pattern within the original string and rotates around that. And you can look at the detail of the code yourself. It's nothing specific to TypeScript, right? It's just a function. But it's this idea, I suppose the only thing is this idea that, look, an argument could also be this kind of a union type here. What's happening here? I don't need to go into that, I don't think. I mentioned this before, but if you've got a function that doesn't return anything, then the return type is void, and that's what I am explicitly stating here. Although I could have left that out. Let's try that. And will it infer the right thing for me? Command K, Command I. And you can see there on did it work it out? Oh, look, actually it did something. It inferred the any. That's interesting, actually. It inferred any as being the return type. So maybe in that case, it would be better to be explicit about the return type, because we don't like any to appear anywhere in our code. So maybe the inferencing isn't always spot on. So I put back in my void. It's not giving me a compile time error, is it? No, it's not giving me a compile time error. But that was interesting, actually. I wasn't expecting that. Let's put our void back in and be more explicit about it. It's okay if it's a one-liner, but if it was a multi-line function, somebody else reading your code might wonder, what should this function be returning? Whereas here, when I'm saying and being explicit, I'm saying it doesn't return anything, then that tells the other readers of your code this function is not meant to return anything. Okay. No, I don't want to look at that now, really. I don't think. Let's go back to my slides. Higher order functions. Again, this is a feature of JavaScript. A higher order function in JavaScript is a function that takes a function as an argument, and strictly speaking, it could return a function as an argument. We don't see the latter that much, but we see the former an awful lot. The former being where a function takes a function as an argument or a parameter. And generically, we refer to that function parameter as being a callback. That's just in the language of in the vocabulary of JavaScript now. Every now and again, like I talk about JavaScript because obviously TypeScript is built on top of it. But so when you've got a callback parameter for a function, from a TypeScript point of view, how do you declare the type for that parameter? And we're seeing an example of it here. Now, this example is it's pretty useless from a usefulness point of view, but it's just how we declare the callback's type. So it looks like this function takes two arguments. It takes a string and it takes a function, which I've called callback, which is a terrible name because that's a generic name. But this is the syntax that you use to tell the compiler that the types of functions that can be passed into this higher order function of mine. This is the higher order function in this case. So this is the syntax here, right? So it's a bit like the arrow syntax. So it looks like this callback, it has to be a function that has a single argument of type string, and it returns a string in this particular example. And coincidentally as well, this higher order function returns a void. That's not significant though. So this is the part here that I just want us to focus in on. When you've got a higher order function, this is the higher order function. How do you declare the type for the callback part of the higher order function's parameters? Well, this is how you do it here. Here's another example over here. And I'm saying down here, you can use type aliasing. That's right. And I need to demonstrate that. Concern now about my clock. Let's see if I can make my way through this example. So here. So I've got a higher order function that I've called array mutator. And the idea is this higher order function is it takes an array of numbers and it mutates this array. And it mutates it based on a callback function that we pass into it. So it essentially calls this callback for each entry in this original array. It doesn't change the original array. It returns a new array, but that new array has the same size as the original array, but each of the numbers in the original array have been mutated or changed based on this kind of function criteria here. And the function that you pass into it, it has to have this signature. It has to be a function that takes a single argument of type number and it returns a number. My higher order function returns an array of numbers. And okay, it's a single line of code. What I do is I map over my original array of numbers, and I'm assuming everybody has seen the map method before. And what I'm passing to the map is my callback, my mutator, which I've decided to call mutator, which is a much better name than callback. Okay, and here I'm invoking my array mutator. I'm passing it an array of numbers, so that's good. And the second argument, which is my callback function, it looks like I'm multiplying each number by 10. So this is my mutator. It happens to be a nice, simple, single statement mutator. But from a typing perspective, it respects what I've set up here, which is it takes a single argument of type number and it returns a number, because that expression does return a number. If I try and do Command K, Command I on that as a matter of interest. Yeah, it has inferred number. I could have been explicit about it, but it has inferred it. Again, you may, as a kind of beginner of TypeScript, you may not have been clever enough to let the compiler infer it. You might be explicit about it, and that's fine. Here's another, okay, I'm just declaring a function here called selective decrementer. That's a function that takes a single argument of type number, and it evaluates this expression here. Again, this is what's this expression called in JavaScript? Trying to think. Can anyone remember what that operator is in JavaScript? Just to explain this statement. So the way this is a JavaScript statement now. It evaluates this. It evaluates the expression before the question mark. If that evaluation is true, then the result of the statement is the expression between the question mark and the colon. If it evaluates to false, then the result is what appears after the colon. What is the name of that operator? Can anybody remember?
I think it's called the ternary operator.
Ternary operator is correct. Thank you. Okay. But back to our mutator. So this function here is a valid mutator because its signature is it takes a number and it returns a number. And I'm using it here in my invocation of array mutator. And again, there's a lot of type inferencing. Well, there isn't type inferencing going on here other than the return type. I'm not stating explicitly what the return type, but again, our friend Command K, Command I, it infers the return type as being number. So that's right in this case. So that's callbacks or higher order functions, and how do you declare the type of the callbacks in your higher order functions? That's what we're trying to get across in these examples. Checking my watch again. Now, I'll just finish on this point, right? So, okay, if we go back to here, that signature there is quite easy to read. But if you can imagine you had a callback which took a number of arguments, then from a code readability point of view, it would take, when people are reading your code, they'd have to read all of the full signature before they kind of grasp what the structure or what the shape of the callback is. Whereas if we had a nice snappy name for what type of function this is, then that would make our code more readable. And that's what I'm doing down here. So I'm declaring a type. This is another use case for type aliasing now, which we haven't seen so far. I'm declaring a type called mutator function, and I'm assigning it a function signature. And that means now that that means kind of up here, instead of having that explicit syntax here, I can insert my mutator function custom type, and it will work for me. And that's what I'm kind of doing down here. So I've got array mutator kind of version 2, but the callback, my mutator, I'm actually using my type alias declaration. And the whole point of this is just to make your code more readable. Now, this is a very simple example, so we're not gaining a whole lot from declaring this, using the type aliasing for declaring my mutator type. But hopefully you kind of get the point. Okay, I'm tempted to keep going, but I won't. If I go back to the website, in terms of the lab, if you've got no experience of TypeScript, then you can certainly get as far as functions. What we need to cover next week are the other parts of the language that we want to look at, which is optionals. Okay, we have done some type aliasing, but the type aliasing that I'm doing here, I think, is stuff that we haven't looked at so far. And generics and utility types. So I need to cover those parts of the language next week with you, and then you will be able to complete this lab. But as I said at the outset, see how far you get in the lab anyway, because labs are intentionally, they're kind of very prescriptive. And you may need to do a bit of Googling around to solve some things for yourself, but so be it. Okay, I am going to stop at this stage. As I said at the outset, I tend to keep talking and not allow people to come in, but you'll get used to it, I hope. Before I close off, are there any questions before I leave you? Now remember, I won't be able to attend the lab on Thursday, unfortunately. That's just for this week. Nobody has anything? Okay, that's fine. You can contact me on Slack anyway if you've got anything that's directly related to what I've been talking about or more generally. Thanks a lot, and I'll talk to you next week. Bye-bye.
Thank
Thank
you.
you.
Thank you.